a conversion unit to another unit. This is also important. Let's say that you obtain the corrosion rate in millimeters per year. You want to convert it into mils per year. So you have to multiply with a certain factors, certain number. Okay. Or if the unit is in MPY, mils per year, you want to convert into millimeters per year, you have to multiply with 0.0254. So these two values is rather important. I guess you need to memorize it for any conversion unit in the later case or later examples. And yesterday also we have looked into a few examples, like for example this one, how to calculate current density and also a mass loss. And when we talk about electrolytic cell, it is important to identify which one will be anode, which one will be cathode. So the position or the assignment of terminality anode or cathode to be actually explained through the position in electromotive force or in electrochemical series. Please remember that the more negative the value of the potential, it means that the tendency of the metal will be more reactive and it can be easily oxidized. Meanwhile, if the standard potential is more positive, it means that the metal is less reactive and it tends to become reduced or become cathode. Here's also another example that we've looked before we end our lecture yesterday. We have a fixed dimension of a container and then filled with a certain corrosive liquid. And after a certain time of immersion, we have a mass loss and you need to calculate the current density, and other things. So this is just an example. And today we are going to look on the other examples as this. Okay, so this is basically a previous exams question, quite popular. You are being, or you are given with a fixed dimension of a pipeline. So please refer to this question. The dimension of a carbon steel pipeline is used to transport sour crude oil that contains 3.14% or 31,400 ppm of corrosive hydrogen sulfide H2S. After 3 months, it is removed for maintenance check. It is observed that the carbon steel pipeline produced a mass loss around 5.2 grams. So by using Faraday's law, predict the corrosion rate in millimeters per year of a carbon steel. So you're given other information, molar mass of the iron, the valency of the iron, Faraday's constant, density, and also some, hint to calculate this thing question is the circumference of formula, which is equal to 2 pi r. Okay, so right now we can list down what will be the information provided. Okay, so time is actually equals to 3 months, right? We also have a mass loss, which is equals to 5.2 grams. Okay, and then other information is the valency equal to 2, molecular weight is equals to 55.85 gram over mole, and Faraday constant is equals to 96,500 coulombs. Okay, right, so if you imagine this is actually a pipeline, it's a hollow pipeline, it's not a closed end, you will think that the sour crude oil actually passed through this pipe, the inner pipe. So obviously, the corroded part will be the inside of the pipeline, isn't it? Okay, right. So for this case, maybe can someone give an idea how we can actually calculate the corrosion rate? What do we need to do first? Or what we need to find first? Cassandra, are you there, Cassandra?
Doctor.
Okay, so Cassandra, what will be your opinion? Let's say that I want to calculate the corrosion rate of this pipeline. Uh, what do you need to find first, you think? Or how do you relate?
Maybe can convert the units to the respective unit first and then substitute in the formula.
Okay, so substitute in the formula. What kinds of formula that you are referring to?
I shall use the Faraday's law formula, Im over rho nf.
I am.
Corrosion rate is equals to the current density times the m divided by density in f.
So you want to straight away calculate the corrosion rate.
Oh,
Okay. Right. You can. So again, what is the corrosion rate formula?
corrosion rate is equals to I multiplied by the m divided by rho nf.
Small I,
Small I.
M divided by rho and F.
Yeah.
Is it?
Yes.
Okay. Right. So did you think that current density value is provided here?
Oh, yes. It's not provided.
So current density is actually equals to current over area. Area, maybe you can find it. Current is not provided. So what you need to do? How do you relate current with a mass loss? Actually, you can refer to the previous formula. Mass loss is equal to IT MW over what, Cassandra?
NF.
Yeah, good. So this is actually the formula that we are going to use first in order to calculate the corrosion rate. But literally, I guess maybe you get the idea that in order to calculate corrosion rate, okay, so there's a few information. Molecular weight is provided, okay, density is provided, valency and Faraday constant is provided, except that the current density is not provided. So if we expand current density, so current density is current over area. Area is also can be found, but current is not provided. So we have to find current first. So if I actually rearrange this formula, you can get like I is equals to M and F over MWT, isn't it? Okay. So this one, I think the one that we need to find first. M is provided 5.2 and F is also provided. MW is also provided. T is also provided. But I think now T is equals to 3 months. Right? So I just want to ask, what shall we do with the time first? Um, Irsalina. Irsalina ada?
Ya, doktor.
Okay, so Irsalina, macam mana untuk time?
Kena convert to second.
Second, convert to second. So how did you convert to seconds? You have months now. 1 month is equals to how many days? Or maybe you can convert into months or weeks or also days. I think maybe we just convert into days first. 1 month is equal to how many days?
30.
30 ke? 31 ke? 28?
Oh my gosh. 30 kot, sir.
30 days. So please remember that whenever you want to convert months into days, okay, please use 30 days as a standard or average days rather than if you use 31 or 28, because you have a variation, sometimes 31, sometimes 30, sometimes 28. But I think the accepted conversion will be equals to 30 days. Okay, right. So 1 day is equals to how many hours?
24 hours.
24 hours. 1 hour?
60 minutes.
Okay, 60 minutes or maybe 3,600 seconds.
Second.
Okay. So the conversion of time, now it becomes what? Isalina. 3 bulan. Macam mana you tukar second? How you combine this?
Sekejap saya.
Semua dah ada dah tu. 3, because 3 months multiply with
50
30
days.
times
24.
24 times
3,600.
3,600. Okay. So dapat berapa?
Seven 7.78 times 10 to
10
power 6
power 6.
second.
Okay. Right. So remember, if you have this kind of question, the total mark is actually 10 marks. So the conversion of time into second, I think with this only it can carry like 2 marks. Okay. Because we have other components. So overall, maybe you to sum all together, you will get like 10 marks. Okay? Separuh markah daripada soalan tu is actually coming from this question, type of question. Right. So now you can assemble, you can put all values together. 5.2 multiply with 2, F 96,500. Okay, so divided by 85.85 multiply with 7.78 times 10 power of 6. So saya nak minta someone to count. Muhammad Hakim ada tak?
Prof.
Yep. So dah kira dah?
Belum. Kejap.
Siapa yang dah kira boleh tulis dalam ruangan chat. We can check after this.
Uh, 2.30
2.3
2.3097
31 lah times 10 power of
times negative 3.
negative 3 unit. Current unit apa?
Ampere.
Ampere. Okay. So I'm just checking whether you guys get the same answer. 2.31 times 10 power of minus 3. Dapat tak? Okay. Right. So ada thumbs up. Mostly thumbs up. Okay. Then now, Yani, I think since you already put into the formula and you, I think, calculate, this one actually can give you like at least 3 marks or more. Okay. First is actually coming from the formula. If you didn't remember how to, if your calculation is wrong, but your formula is correct, then you can get like at least 1 marks. This one is also another 2 marks. Okay. Right. And then now, what's next? Next is actually to find area, right? Because we want to calculate the current density. So if you want to calculate the current density, you need to find what is the area. In fact, if you use another version of a formula, okay, you still need area. Okay. So now, just asking, like, if you look into this pipe, right, it is cylindrical and it is hollow. So how actually we want to calculate the area? Anyone have an opinion on this? tanya Nur Aisyah. Nur Aisyah, are you there? Aisyah ada? Tak ada. Okay, so Nur Khairin Kamalia. Kamalia, ada tak? Pun tak ada. Ui, Chia Chun. Chia Chun?
Yes, doctor.
Okay, alright. Don't be afraid. Okay, so just want to ask you your opinion. It's just, if you don't know, so it's okay, no problem. I'm not going to blame you. Okay, so what do you think? If we want to calculate the area, and since this is actually a pipe, so what do you think? How we can actually calculate the area that is exposed with corrosion? As I said, this is a pipe, and the corrosion occurs inside the pipe. It's not, occurs outside the pipe.
Yeah.
And you are provided with the diameter, the external diameter, and also the thickness of the pipe.
Okay. I think is the total diameter is 20, so the radius will be 10. So to get the internal radius is 10 minus 2 is 8.
Hmm?
So to calculate the area is pi r squared using 8 as the radius.
8, Okay. Right. So first, maybe we can calculate the internal diameter. Okay. So since the external diameter is equals to 20 and the thickness is equal to 2. So you have 2 over here, 2 over here. 20 minus with 4, because we have like two sides. We're assuming that this is horizontal. And this is actually equals to 16 centimeters. Okay. Radius is equals to diameter over 2. 16 minus 2 is equals to 8 centimeters. Okay, so I think she actually answered it right. Okay, so once you get the radius, the internal radius, so what are you going to do with it? Chia-Chun.
So calculate the area using the radius, right?
Okay, you want to calculate the area. So how you are going to calculate the area? Hmm.
Pi r squared.
Pi r square. Okay, this is not this is not a flat sphere. It's I think a tube. Okay, I think you can actually use this one. You see, I put this circumference. If you assume that this pipe, I just cut one part of it. Okay, and then after that, I open it. So from a cylindrical pipe, okay, it will open as one piece, right? Okay, so this is actually the area that you want to calculate, because this is actually the inner pipe, and we already know what will be the the radius. Okay, length is provided. I think length is equals to 20 meters, and the circumference. This is actually the circumference. Okay? Circumference is not provided. You have to calculate, and circumference actually will equals to the width of this thing sheets. So therefore, circumference is equals to 2 pi r, which equals to 2 times pi times width, the radius. So what would be the radius that you are using here? Chia-Chun. Chia-Chun, 10 or 8?
8.
8. It should be 8 because we are talking about the corrosion that is occurs inside. So we already find what would be the internal diameter. Okay, so from there you can know what would be the radius, and this is actually the radius that belongs to the internal part. Okay, so can you calculate this, Chia-Chun?
All right. 50.3,
80, 50, 50
50.32.
point what?
32
32 centimeters.
centimeters.
Okay. So this is actually the circumference, which actually equals to the width. So the width now is equals to 50.32, and you have the length, which is equals to 20 meters. But of course, this is not the same unit because one is actually in meters, the other one is centimeters. 1 meter is equals to how many centimeters? Maybe I ask the professor. Thank you, Chechun.
Right.
So Ishan, are you there?
Yes, doctor.
Okay, right. So 1 meter is equal to how many centimeter?
100.
100. So how do you convert the length of the pipe? 20?
To 0.2 meter. Sorry. That is 20 meter. 20 meter. I cannot see clearly, sorry, doctor. 20 meter is equals to 2000 centimeter.
20 times with 100, so you get 2000
Yeah.
cm. So the area now, okay, you can calculate by multiplying the width and also the length, which is now 50.32 multiplied with 2000. Can you calculate that?
Yes, doctor.
What is the value? $50.32 multiplied with 2000.
100,640.
1
00
0 0
640
640
centimeter,
unit
centimeter cube. Square.
square. Okay, so this is actually the area. Just checking whether others got the same answer. Can give a thumbs up. Good. Okay. Right. So now I think everything is complete. We can actually calculate the current density. But before that, I think the conversion or the calculation of circumference, this also will give you marks. And the calculation of area also will give you marks. Okay, so now we already have 5. Okay, so 5, maybe this one 1, and this one is also 1. Okay, 7. So the remaining 3 is actually by putting the the current density and finally the corrosion rate. So current density now it becomes 2.31 times 10 power of minus 3 divided by 100,640 centimeter square. Please calculate that. Siapa Syafiqah. Dapat berapa Syafiqah?
2.304 darab 10 negatif 8.
2.304
304
darab
10 negatif 8.
negatif 8 amperes over centimeter square. Okay. Checking. You guys get the same answer? Betul ke? Dapat jawapan yang sama? Okay. Okay. 2 orang kata okay. 3. Okay. So I assume it's okay. And finally now, you can put into the formula to calculate the corrosion rate. Okay. So yang ni pun akan dapat markah. Corrosion rate now is equals to, if we refer to this formula, so 2.304 times 10 power of minus 8 multiply with 55.85 divide 7.85, sorry, 7.8 Yeah, 785 multiply with 2 multiply with 96,500. So final answer, I want Tan Sok Jing to calculate. Sok Jing?
Yes, Doctor.
Okay, so you get the answer?
8.49 times 10 power of 13.
13, 13
13.
minus 13,
Hmm.
Okay. MMPY. So remember, for this formula, the unit is in millimils per year. Okay. Checking. Others? The same answer? Good. Okay. Right. So I hope that you guys able to understand, okay, how actually you can calculate the corrosion rate based on different sets of, I think, materials or dimension. Like in this case, it is a pipe. So you have to understand, in order to calculate the area, we have to look into the inner part of the pipe, and we have to use, I think, formulas like circumference formula, whatsoever, to get the idea of getting the area. So let's say that I want to convert this corrosion rate in MMPY to MPY. Okay, so what should we do? Um, Umira Fitri. Apa kita nak kena buat if we want to convert this MMPY to MPY unit? Tak ada Umira. Syafiqah.
Yes,
Ah,
Doctor.
ada. Okay.
Ada.
Umira.
MMPY to MPY
Yes.
times with 39.4.
Okay, so if I give another example to calculate in MMPY. So, okay, so MPY, MMPY, 2 MPY, okay, 8.49 times 10 power of minus 13 multiply with 39.4Y. Dah, Mira?
Ya, Doctor. Ya.
Dapat apa?
Wait.
Sorry, 13. 3 minus 13.
3.35 times
3.35
times 10 to the power of negative 11.
11 MPY. Okay? Alright? So clear ke? Ada apa-apa soalan? Any question so far? So please get ready for your next quiz. Okay? I think later in the afternoon I will post your next quiz, which is related on calculating the corrosion rate. So make sure that you understand how we are going to employ Faraday's law and to calculate different sets of questions, like to calculate current density, corrosion rate, and whatsoever. Okay. And now we are moving on to the factors affecting corrosion. Okay. Briefly, we have a few factors that can affect the corrosion process. It could be coming from the material properties, when the chemical properties determines the energy consideration necessary for corrosion to occur. And for that, we also have a different sets of factors, like for example, metallurgical factors. In the pure metal, anode area are grain boundaries or small micro heterogeneities. In alloy and metals with impurities, you can have chemical segregation, presence of multiple phases. I think multiple phases we have seen in chapter 9 in phase diagram, where if you produce an alloy, then you have a possibility that the metal is not homogeneous, then you can have a multiple phases. Okay, and then after that, the impurities also can come from the inclusion, defects, and non-uniform stress. Surface condition can also affect corrosion process. So surface condition inhibits electrochemical action between the metal and its environment. So the formation of oxide film, uniform oxide film, okay, can also, I think, contribute to these thing factors. That is why I think if you compare, you have stainless steel, you have a stainless steel. Can you actually think why stainless steel didn't corrode? Okay, because in stainless steel, actually you have a very thin oxide layer or passive layer that is known as chromium zinc oxide. So the chromium zinc oxide layer is a very passive, it's very stable, and it is an oxide film. Then this actually can stop, I mean, the further oxidation of iron. Okay? And other than that, a film of adsorbed gas and also surface defects can also affect the corrosion process. And other than that, other factors could be coming from environment. Okay, for example, the chemical nature, you have acid, base, salts, gases, or solvent in your environment. So all these actually can contribute to I think, anything affecting the corrosion process. And finally, the operating condition, which related with the temperature, velocity, concentration, impurities, and also aeration. So moving on, today, I think we are going to look also on the types of corrosion. Okay, so for corrosion, we have different types. The most common one, the first one is actually known to be general or uniform corrosion. So this is quite easy. This is something that you can see, around you, where uniform attack is a form of electrochemical corrosion that occurs with equal intensity of the entire surface of the metals. So in this case, metal will corrode uniformly all over the surface. So you wouldn't see any like localized or spot corrosion. It will actually occurs uniformly. Second one, we have localized corrosion. Okay, so localized corrosion, the corrosion occurs at the one specific site. Okay, part of the structure corroded at considerably higher than the average rate. It can also be categorized, okay, into different types. Right? For localized corrosion, you can have pitting corrosion, crevice corrosion, galvanic corrosion, intergranular, selective, and also filiform. Okay, so for the types of corrosion just now, types of corrosion. Okay, we have uniform corrosion or general corrosion. We have localized. And for localized, you can have pitting, you can have crevices, galvanic, intergranular, selective, and also filiform. Okay, so another types will be on combined effect. This one I think we will see it later. So we're going to look into each category for localized corrosion. The first one is actually on pitting corrosion. Pitting corrosion actually the formation of small pits on the surface of a metal or alloy. The corrosion effect is concentrated on localized area and leads to the pitting, downward propagation of small pits and holes where passivating layers fail. Okay, so for pitting corrosion, it is quite special because this occurs underneath a protective or a passive layer. In examples, you have like metals, okay, stainless steel, as I said just now. You have a stainless steel, but what happens is that this stainless steel have some maybe exposure to scratch or defect. As a scratch, then the passive layer or protective layer actually have a hole. So this hole can provide gaps for oxygen and water to penetrate. And what happens is that corrosion process can occur, okay, underneath the passive layer. Okay. So in order to explain the pitting corrosion, you need to explain what will be the definition of pitting, and also what will be the formation that you will see. You need to draw. Right? So moving on to the next one, crevice corrosion. So crevice corrosion is a consequence of concentration difference of iron or dissolved gas in electrolytic solution proceeds at location covered by a corrosion product and other deposits, for example, dirt or trash. So crevice corrosion typically occurs in a small cavities, gap, recession, and etc. So for this type of corrosion, normally occurs in small gaps. You have like maybe a connector between one end to another end. So what happened is that um, this material is being joined together using a bowl or screw, okay, and you have a gap. So this gap actually can trap dirt, okay, or other types of material, small material, which could be porous and easily trap water or moisture. So at the end of the day, you'll see that dia banyak ada habuk kat dalam ni. And if let's say that it is wet, then this part could be considered has a higher concentration of water, and this metal can be exposed to corrode easily rather than the other part, which is dry. Okay. The third one for localized corrosion is known to be galvanic corrosion. This is quite special because for galvanic corrosion, it occurs when two metals having different composition are electrically coupled in the presence of electrolyte. Okay, so you can actually imagine that you have two materials, like for example this one, you have a screw and you have O-ring, which is made from different materials. One actually made from iron, the other one made with zinc or whatsoever. So it is actually attached together, okay, attached together and exposed to the same environment. So the same environment is actually, I think the environment can be assumed as the electrolyte, and the two different metals can be considered as the electrode. So this actually creates a so-called galvanic effect where one will be anode and one will be cathode. Of course, the one that is more active will be anode and the other one will be cathode. Right? So there's a few criteria. I think this criteria for galvanic corrosion you need to know. Okay, at least it involves two different metals. It is electrically connected or attached, and it has the same environment or electrolyte. Okay, so next one is actually on the intergranular corrosion. Okay, so intergranular corrosion is basically a corrosion that occurs along the grain boundaries, but often special phase exists. So in this case, if you have alloys, which not homogeneous, then you know that you have a different phase, and the phase is separated by phase boundaries, and the phase boundaries is actually quite weak, so it can actually be oxidized, and because of that, it can easily crack or can damage the material. Okay, so next one we have a selective corrosion. When one element or constituent of metal is selectively corroded out of a material, it is referring to as a selective corrosion. The most common example is the zinification of brass. After leaching had occurred, the mechanical properties of the metals are obviously impaired and some metals will begin to crack. Okay, so these examples you can see for, I think, galvanized steel materials where you have a zinc coating, and when it is exposed, zinc will be leached out, and then I think the mechanical properties will be impaired. Okay, And finally, we can have filiform corrosion. So filiform corrosion is another type of localized corrosion where the surface corrosion of the paint film remains intact, but the addition to the substrate is destroyed, causing a trail or underfilm corrosion to form, like a worm tracks. So this one you can see a lot in CD. I think those days we have CD. So CD is actually made from aluminium, okay, substrate, and it is coated with plastic. It is, I think, sealed in plastic. But what happened is that the coating is actually quite brittle, and it can actually absorb oxygen and water. And what happened is that the corrosion process occurs underneath the coating layer. So it will actually forms like a track, worm track. Okay. You can also see in, I think, some stairs, or I think railings, railings near to the ladder, or stairs, where when you actually apply a coating like paint, after a certain time the addition is not really good, and you can see that corrosion start to occur underneath the paint layer. So this one actually we call it as filiform. So don't be confused with I think pitting corrosion, because pitting corrosion occurs only on the passive layer where the passivation layer fails. But for filiform, actually it occurs underneath a coating, like for example paint, or any seal. Right. So I guess maybe for the combined effect of mechanical factors and corrosion, this one probably we can continue in our next lecture. Okay. But before that, is there any questions so far regarding on calculating the corrosion rate, and also what we have learned today regarding on types of corrosion, generally on uniform corrosion and also localized corrosion? Any questions so far? So please remember that I think yesterday or day before yesterday, I have told you that you have a group assignment in the form of video presentation that you need to do, is to explain methods for corrosion protection. So the grouping is actually refer to the previous grouping done by Dr. Chua. You can use, um, do in the same group. Okay, so I want you to prepare a video. So basically, I just want you to submit next week, end of next week, after Chinese New Year. Okay, so probably you can start to think of ways and how to, as I said, there's a 5 major things that you need to concentrate in corrosion protection, and probably you can prepare like a video, or you can prepare like a slide presentation, something like that. Okay, recorded. All right, so I guess that's it for today. I will stay back just for a while to answer any question. If you don't have any questions, so I would like to thank you to everyone who attended the lecture today. And of course, in the afternoon, I will post your quiz for today. Okay, so with that, thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.